So today we're going to talk about overlapping generations dynamic models eventually. I have lecture notes from a paper I wrote a number of years ago. I've been working on OLG integrated assessment models with Chris Boner. So I don't have anything really to share from that yet, but I've been back into this recently, and I've gone back to our earlier paper, and I found the lecture notes and the distribution materials for multi-sectoral OLG models. It's this one. It's Sebastian and I worked on some material for a dynamic general equilibrium modeling workshop at ETH. I think it was 2012. So I have all the materials from that in the lecture notes, so I'll go through that. However, I was yesterday afternoon. I walked out for lunch, and I think I got heat kind of. Anyway, I don't know what it is. Like the dog ate my homework, but I just felt like I was not really firing on all cylinders yesterday afternoon. So I didn't feel like we did a very good job on this sort of how to manage a model. And so I worked on that yesterday evening and this morning. And so I've got a revised version of the little oil market model we developed with some new insights into the model. It's kind of interesting. It's always fun. One of the things I like about modeling is that you don't know the answer until you actually get stuff together. And so it helps you sort of think through what you're doing. And you can imagine there's all sorts of potential arguments or mechanisms which could hold water, seem plausible. There's all sorts of arguments that can influence political dialogue and policy dialogue. But I'm convinced it's not always possible. There are many of these arguments for which it's not possible to come up with a model that demonstrates that mechanism. Right? So it's easy to persuade people that there's mechanisms potentially important, but then to actually demonstrate this conclusively. I saw a bumper sticker this morning coming in that I thought was right on target. It said, "Don't believe everything you think," which I think is really that's exactly what we're about to do. What we're out to do is to figure out not to believe everything we think. So this is what I have planned for today. I'm going to start off this morning going through PSA and SSA. And I've taken this little oil market model and I've produced. I call it instrumenting the model. So how to set up a model. Like you get a GAMS model, you want to make sense of what's coming out of it, and you want to do it in a systematic way, and you'd like to develop graphics and tables that capture the results across things. So this is really what an industrious research assistant has to know how to do, right? And so this is how do we help out? And so if you're the GAMS modeler, or even if you're just a person who has GAMS on your PC, it's helpful to know how to build the tools to instrument a GAMS model and get the results back. So I tend to, in my mind, I like to have simple ways of thinking about things. I like to think about PSA as piecemeal sensitivity analysis, where I want to run a set of scenarios. Each scenario is a collection of assumptions, and then I want to compare across those scenarios. That's a one-dimensional set of scenarios we compare across. Or I want to do something that's a SSA, where I have multiple inputs. I want to look at all combinations of input assumptions and see how they interact. So those are the two types of things. And so I have for this, and we have this little, single sector, this very simple little oil market model that captures this idea. So I think that would be, my inclination would be to first go through this with that model. And the idea is it's sort of a compelling one. It says, okay, we want to stop, we want to sanction a country by restricting imports from that country, or implement a sanction. But if that country has a sizable fraction of the global supply of a particular product you're trying to sanction, one of the effects of sanctioning their purchases is that you drive up the international price and you drive down the price of the output. If it's a sub-global agreement, then you have leakage problems, that emissions, that you have an economic incentive for people to bypass the sanction. So this is a simple model to capture that idea. I mean, we can dress the model up by giving names to what we're doing. So we have, crude oil being produced in multiple regions. It gets purchased to produce refined products. we're going to basically restrict crude oil trade from one country and then see what happens to where the trade goes. And then we want to try to see, how does that depend on the assumptions we make. So that's the model we spent time doing with today. So that's what the game plan is. One other thing that came up that I thought was in the discussions, again, the commerce folks are here, so they get my full attention because I can see them, right? So I really appreciate having people here. I'm tempted to implement the same rule that I implemented in my globalization class last year. I had 50 students in the class, and if 10 people didn't show up, then I didn't post the lecture notes. So the people who came got to see the lecture notes, and so I'm tempted to do that with WiNDC in the future. It's like, if I don't get 4 people here on the ground, then I'm not gonna post the lectures. I'll run the lecture for the people who are here, but forget it. So anyway, it's been good having these folks here. One of the things that we came up with, commerce is like, they're the first line of defense against crazy proposals for trade and policy reform. And so these guys, they're right on the firing line, right? They're right at ground zero, and everything has to be done like yesterday. And they want lots of detail, and the interested parties are interested in what happens to their industry, and those industries are not restricted to ones that are in GTAP or WiNDC. So one of the things we've been chatting about is how to get better sectoral resolution. So your tolerance for imprecision in the database is a direct function of how important it is to have the sector in the database. So there's certain sectors, we need that sector. If the data is not correct, so be it. I have to have a number. The challenge, right? So that's the situation we're in. And so one of the things Natalie and I have been talking about, okay, if we have to have a number, where do we go to get that number? And so I've been looking around. I came across, I'd interact with these guys like 5 or 6 years ago, and I found some stuff I couldn't make sense of in their data set. I hadn't gone back to it, and it turns out they've done a lot of work on that. This is this Exio-based sort of input-output table thing. So I've written some code for reading that, and I think that I'm hoping to work with the commerce folks on developing a version of this we can use to disaggregate the WiNDC and the GTAP data set. It's not something that's intended to replace the sectors in GTAP, but if you want to go out and do if you need to have some sectors you don't have, then it's helpful to basically have that stuff. So I thought I just this morning would sort of together would look at that data set and sort of talk about it. I'm happy to get input from the folks at EPA. If somebody there knows about the data set, it has lots and lots of emissions data. So if anybody there wants to turn on the microphone and talk to us about it, we'd be happy to hear from you. But otherwise, so those are the 2 things I'm going to do this morning. My game plan is to get from now, and then I'll start doing the OLG stuff from about 10:30 to 12, and then we'll come back at 1 to handle additional questions from the group. So I don't think we'll go all day today, but we'll go some bit of time into the afternoon. And then my intention is to set aside the afternoon to work with these guys on things of interest to commerce, because they showed up, right? So that's the objective. Okay, so let's go back to PSA and SSA. Was that? Yeah, good. It's all about, that's what they always tell you in yoga. It's all about showing up, right? Okay, so I'm going to share my screen. Just close some windows here. I'm going to share my screen. Okay, so I'll say share screen. And I just want to go through, so I fear that yesterday I was a little bit flaky and I didn't really explain stuff very well. So I'd like to go through this in detail, because this is something that's very general, right? This is a dead simple little model, but the techniques I'm using, you can use for any model, right? So let's just look, I have model, if I look at the GMS files I have here, model.gms. So this is our oil market sanctions model. So this is a GAMS code. It has regions, G20 regions. and then we have coalition regions and a target region. So now, I'm going to be like ridiculously pedantic. So I'll just go through the code and explain all the features, recognizing that most of you already know this stuff, but I'm just going to go through it anyway, because it's good to be thorough. And so we begin with the names of the regions. In GAMS, GAMS doesn't care if you have a carriage return without a comma, it assumes you meant to put a comma in there. So usually the way it goes for set declarations is you declare, say, I'm going to tell you a set, and then it looks at the set element, and then it assumes if there's no dot after it, it assumes, okay, now I have descriptions for that set element. So you can think of a set as being it's basically an array with with text labels and text strings that go with each label. So you can think about the data that comes with a set as being the descriptive text. And here it's going to presume that because they're uncomma, there's going to be, this would be exactly the same. If I put commas at the end of each line, then that would be exactly the same. Should be that's there. It doesn't, GAMS doesn't care about the commas, it puts them in for you. I personally, that's one thing I don't like about GAMS. I wish that they had produced a version. I wish they had a switch. Fortran, it's called explicit none. But I wish there was a version of that for GAMS, but there's not, where I say, okay, everything has to be tightened down. Now, one of the things, if you want to put a comma, if you have a descriptive text where you have a comma in it, then you want to put you'll want to put double quotes around the text. And so you can put the double quotes in, there's not a problem. But here it doesn't matter that we don't have double quotes, because it's going to assume that. Okay, so that stuff all goes like this. And then I'm going to declare a subset of R. And so that's why I say R coalition of R. It says now I want to identify some elements of R as being a subset of R. So that's the way this is sent. And GAMS will double check when you say R coalition of R, it will check to make sure every label you put in that subset is actually in R. So it's doing index checking for you. When you declare it this way, it says, okay, I'm going to look for elements of R here. And then I'm going to say, well, oh, whoops, I have to sometimes have R and I want to have R prime. So I want to have two ways of referring to set R. Okay, I'm going to declare an alias. So the set statement concludes at the end of this declaration with a semicolon, and then alias is a new name. My editor knows a little bit about GAMS, so it knows alias is a GAMS name, so it puts it in red. The editor is a little bit out of touch with GAMS. It's maybe a few years out of date. It doesn't know the word singleton because that's a new idea. If I declare a set as a singleton, I say, okay, now I have a subset of R with just one element in it. And if I declare a thing as a singleton, then I can stick it on the right-hand side of an, it doesn't have to be controlled. So singletons can be used anywhere, whereas any set that you use on the right-hand side of an equation, it has to be controlled on the left-hand side, either through a GAMS assignment or an equation. So here we have a singleton that's a single set. And now I have the stuff that's going to be defining environment variables used for sensitivity analysis. So this is what I call instrumenting the model. So you get a GAMS model. The first thing you want to do is instrument the model, meaning put in environment variables for the things that you might want to change. The environment variable is just a string substitution. So I say, if not set epsilon, that says if epsilon has not been provided on the command line of the program, then I'm going to give it a string. And so set epsilon 0.1 assigns to environment variable epsilon the string 0.1. It trims off the leading space and it just gives you the number. So it's strictly a string substitution. It doesn't know that's a number. It just knows that that's a string that it's got. Right? So that's I've defined 3 environment variables there. And now I have parameters for the model. And in the model I could have this varying by region, but I haven't. I've just assigned common values because I'm just saying on the first pass. If, for example, I wanted to say eta is the price elasticity of supply for crude, I could, for example, say if not set eta SAU, so that's the price elasticity of supply for Saudi Arabia, set ADA underscore SAU to be 8 or to be 2. And that would add an additional control. And then down below, I could say ADA of SAU is equal to ADA underscore SAU. So that then gives me an additional control. I have the 3 controls. I've added another one where I have ADA as the common elasticity supply for everyone. And then I have ADA for SAU says how responsive is Saudi Arabia. And I could make it, that way I could do simulations where I have one region being different from the other ones. And the Saudis' response is going to be, in terms of the effects on oil markets, it's going to be probably bigger, and you might want to think about understanding that. So you have to ask yourself, what are the scenarios I want to run? And that drives what the instruments are you want to control. Yeah. I first make the assignment to ADA for all of them. That's the default assignment. And then ADA SAU does a second assignment. So GAMS, this is where GAMS is a procedural language at this point. So it does this assignment, that assignment, that assignment. So the order in which they're done. Yeah, it's just a regular. Yeah. So that's why, so I'm just showing you that you can put anything in here you want to, right? Right. So normally in GAMS, they talk about when you're a beginner, you have a GAMS program, and then you go in and you manually go in and change the number and then run the model and then write down. And the basic, the novices sort of introduction to GAMS sort of has this image that you've got a pad of paper next to you and you're running the model and writing down the results and then run it again. So here, this is the way you don't have to do it that way. You have control over it. And notice that once I have it there, because of this having a default assigned, if it's not there, then it's fine. It doesn't create a problem. Right? It's like having additional stuff is not a problem. So I'm just showing you what the controls are. I'm going to remove this just to avoid confusing things, but that's gives you an example of how it works. Okay, so these assignments and the percent is just like a string substitution in a DOS batch file. So if you don't know what that is, then this is not helping you. But if you programmed with DOS batch files, then you know about environment variables or something you use quite commonly. And one difference relative to GAMS as a whole is that in GAMS is not case sensitive in the programming language. So the variables parameter sets, not case sensitive. However, the string substitutions that are done through the environment are case sensitive. So that's just, they decided to make it be, rather than having a different set of rules for GAMS than for DOS, for batch files, we're just going to use the common rule. So the case sensitivity is something that inherits from the way it was implemented. So that assigns them all. Now we come to the benchmark sales, and this is the simplest possible model where we just basically read in one parameter that describes what the existing transactions are, and that's going to be declared as a table. So a table is a human-friendly representation of data where we have columns are lined up. And so we say X0 of R, RR. Notice that RR is the same as R, it's just an alias, but I'm just using it just to distinguish between the row index and the column index. And then the way a table works is it's the text alignment that determines how stuff gets assigned. So the fact that 107.7 is under CHN, that tells us that China's sales of crude oil to China is 107.7. Right, so that's the way this. And so here you see, and this is, in some sense, that's the reason we want to have a model. Is we want to have a model because we want to take into account what the range of sales are. So, for example, the Russian sales in the benchmark Russian sales of oil to China is roughly a third, or maybe 40% of its domestic supply, and it's about equivalent to what the sales are from Saudi Arabia, and China's imports from other oil exporting countries is nearly 48%. Actually, low-income countries have some oil production. So you can see that there's lots of oil coming to China from other places, but Russian supplies are roughly 40%. And you can see the same thing here. Let's see, I think if we look for Germany, let's see, So there was middle income countries. Let's see, where did Germany go? So if I go down the German column, 1, so 31, and that's, so the dominant, if I look at Russian or German imports of oil, it's 14.5 comes from middle income countries, that's other oil exporters, but 31. So it's the dominant amount. We see that Germans' oil imports are largely from Russia. That's the dominant. So this table tells us something about the world. And we ask about why we build a model. Part of it is it provides us guides as to how to look at what the world looks like. So the way I've calibrated the model here is I just read this one table and then I say, well, demand for crude oil or for oil is the sum over of the imports, and it includes the diagonal terms are domestic supply, and the supply of oil is the sum of the exports. And I'm going to use in my model, I need to know value shares. I'm neglecting taxes that may be applied, so I didn't pull out. We have the general equilibrium data set has lots of details, but I just pulled out this one table just to make the model as simple as possible. You know, there are taxes in the GTAP model, so you could go out and get the taxes. There's other data you could get to parameterize, but here I'm neglecting taxes, so that means that the value share of region R exports into region RR demand is simply X0 divided by D0. X0 of R to RR divided by D0 of RR. So now it's helpful when you write down a model, you want to basically avoid, at least this is my habit, is to avoid if there's a region that has no data, there's no production, rather than carry the zeros around, I like to try to restrict my attention to those activities which are really meaningful. And so therefore I create a set called RY. That's the reasons for which Y is non-zero. So that says RY is equal to yes. So I'm declaring a tuple, a subset of R, and the elements of that tuple are the ones for which Y0 is not equal to 0. And that's what this assignment says is RY of R is equal to yes if Y0 of R is greater than 0, no otherwise. Right? So the no otherwise is if that becomes, if Y0 is equal to 0, then the yes goes away and you end up having an assignment equal to 0, which means no. So that does an assignment to every element of R. The conditional is on the right-hand side. That means that the assignment is done for every element of R, and the ones for which the conditional is false, those will be assigned equal to an empty element on the right-hand side, which gets assigned to 0, which means no. So that's how you handle logic. So now we declare a model. It says we're going to have product demand in region R, product supply in region R, crude oil sales, and then I'm going to declare the output that I'm going to have a CS composite of crude oil from multiple places producing something I'm going to call petroleum products. Again, I've not brought in wage costs of refinery workers. I haven't brought in even the capital costs. So that'd be a nice extension of this model is if we account for capital cost, does that change the story? I haven't done that here. So I basically combine petroleum products together and I produce this price. P of R is the product price, and C of R is going to be the supply price. That's the producer price is of the crude. So that's the wellhead price of the crude, and then you have the price at the pump is going to be interpreted as P. And then we're going to put in an instrument. Notice it's declared as a variable rather than the parameter. In Jim's examples, he always would have taxes were parameters. Here we're going to do something with an endogenous instrument. So I put the instrument in as a variable in the model T, and T of R, RR will be the crude oil tax rate on production from R that gets sent to RR. And so we have an equation that, and we declare then the equations that go in the model: demand, market, supply, input, and price. And so let's first write down supply. The supply is an upward sloping supply function. The reference level is Y0. When C of R is equal to 1, Y of R is equal to Y0. So it's a calibrated supply function with an elastic supply equal to eta, isoelastic. The demand function is downward sloping. So I'm interpreting epsilon to be a positive value. So therefore minus epsilon goes in the objective, in the as an exponent, and when P of R is equal to 1, then we get D of R is equal to D0. And then oil output in region R gets shipped to all the regions, RR. So there I'm using both two references to the same set. And notice, oh, that's also something I should have pointed out. Up above here, the supply equation. Notice, and this is just the GAMS syntax thing it's, I remember early on in GAMS, I found this confusing and now I use it all the time. So it's like, so I have a subset RY, but I like using R to index region. So therefore the region way to index, to restrict the equation to only generate the ones that are in RY, I put the RY, I wrap that around the R in the definition of the equation. So that's out supply of RY. And then that ends up restricting we only generate equations for the ones for which RY is true. That's right. Although the thing is, the fact is, now I'm doing the declaration, I could assign the RY anywhere before the solve and it wouldn't matter. In other words, at this point, when GAMS is reading the equation here, that's the declarative part of the model. So anything we do prior to for RY, in other words, what I'm saying is I assigned RY here, but I could just as easily go down to where I could put RY here. It has to be declared, but then the assignment doesn't, it just has to occur before the solution. Okay, so there's the supply function, there's the demand function. I know there's petroleum demand in all regions, so therefore I don't need the RY over there. I know the market, the output market from crude oil is only applies to the regions which are producing crude oil. So that's Y of R is equal to sum over RR of X of R to RR. So that keeps track of the output. And then we have, well, how much industry output do we have? And that's going to be equal to an index. Let me just, I can write it this way. It's going to be X0 I have here. So let me just, another way of looking at this is going to be D of R is going to be, that'd be another way of writing the same thing. That simply says, how much crude oil gets from region R gets shipped to RR. And this guy would be, that's going to be X of R to RR is the benchmark shipment, that's X0, times an index that represents what happens to aggregate demand. So that's the aggregate demand index. In Matheson's framework, remember that we have the net put vector A and we have the activity level Y. So the activity level is going to be D divided by D0. That's the level of the overall demand. So there's a scale effect and there's a substitution effect. Substitution effect is the change in the demand coefficient, and the demand coefficient is what follows on the right hand side. That's the CES term that relates P to the tax inclusive import price. So C of R times 1 plus T of R to RR is what the gross of tax cost is, and P of RR is what the overall cost of products, and that gives me the demand function. And then finally we have the CES price index depends on the value shares. That's theta of R to RR of R to R and what the deliver prices are. So this is all, and so to understand equation input and price, go to the lecture notes from yesterday morning on CES functions. So that's basically, those are all demand functions for, those are CES demand functions and cost function. So P of R is defined on the basis of the cost of the constituent crude inputs. Okay, and then that gives us then an equilibrium, which is defined by demand, market clearance, output supply, the supply response, the input, the compensated demand input, and the price equation. So we declare, and again, just to remind ourselves, we declare an equilibrium model through a declaration of the equations, followed by a dot and the corresponding complementary variable. So now, just as a necessary condition that the model makes sense, is I should be able to if I put the policy instruments equal to the benchmark levels, that I set the T's all equal to 0. If I do that, then it should be the case that I replicate the benchmark equilibrium if I've calibrated the model properly. So this is just to check my calibration. So I assign the benchmark values. I keep track of what Y's I want to have in the model. That's through the assignment of RY. And then I declare the iteration limit to be 0. And that's essentially, so this tells, so here I'm going to say, crude oil produced again, we could add something where you could make a different assumption, but here, because it's a calibrated model and it's smooth, I'm calibrating assuming that if there's no crude oil produced in the benchmark, there's none in the counterfactual. So that's where the RY gets assigned. And here we're going to say setting the iteration limit to 0 instructs path to evaluate the functions, the equilibrium conditions, the equations, and report the precision. Okay, so that's what I'm telling path iteration limit 0 says don't touch anything, no iterations, just evaluate the function. So that's just, it does a function evaluation, and then after doing the function evaluation, we assess So if the magnitude on e to the minus fifth, if this happens, we are not replicating has to be a short circuit between the headphones. Right? That's just saying, okay, check it. If it's not right, then stop. It doesn't mean the model's right. It's a necessary but not a sufficient condition. If I've got the model right, it's got to be balanced, but there still could be off. Okay, now after having set up the equilibrium problem, we then set up and replicated and checked the equilibrium model. We declare an objective function which can endogenize tariff rates. Okay, so what are we going to say? It's going to say value, so the objective function equals value of crude oil sales at producer prices with the target. Right, so C of R is the producer price, Y of R is how much they produce, that's how much revenue they get. Okay. That's going to depend on, okay, well, the sanctions will then be all equations. So here we're going to declare a model. all the equations which have been defined to this point. This will be used in nonlinear program. So we don't have a mapping Okay, so in the equilibrium model, I was being very careful. I just associated with equations code. Now I'm going to declare a variable that has the objective function. Essentially, what we do is we have a set of equilibrium variables, prices, activities that solve that square system. And then when we solve the nonlinear program, we're going to release the tariff rates, and those are additional variables which will be determined by the optimization. So we can think about, even though it's all determined simultaneously, you can think about it as the optimization determines T, and all the other variables get defined by the equilibrium conditions. Okay, so now I'm going to permit tariffs when I did the replication of the equilibrium model, I set T to be equal to 0. And now I'm going to permit it to be up to 20. It's just, I want to keep it from going to something crazy. It shouldn't be 20. 20 is a really high tariff rate. So my guess is that's going to be, I want that to be non-binding in the solution if I can help it. And now we have, so no complementary selecting conditions. So we declare this, and I say solve the model minimizing OBJ. So we're minimizing the revenue that's earned by the target region. And then I'm going to declare some solution values. And here I'm going to be very sort of careful. I'm going to write down what the names are of all the items that go into the percentage change report. So I declare that set, and then I declare a parameter over that set. So that way it'll give me an error message if any of these are violated. And then I generate the report. I report the percentage changes, but I'm going to say, okay, let's just drop anything that's less than 0.1 in magnitude. I don't care about it. So that way it'll still show up as blanks. Now, what am I doing here? M is going to be imports from the target region to R. So M of R for CT of R is going to be based on the imports, and X is the exports from all regions. And that says those are sales X to regions other than R itself, right? So exports, percentage change, the benchmark level is X0. So X of R to RR is the sales of R to RR, but if I want it to be exports, I want to omit X of R to R. So that's what I do here. I do a sum over RR such that the RR is not the same set element as R. So that's the GAMP syntax for keeping track of whether two elements are the same. R and R are the same set, so I'm just going to do a sum, except I'm going to omit the diagonal. Alternatively, let me make a comment here. Find the same as operator function confusing. You could also alternatively write use I'm just going to show you this because it's another way. So you could also use sum so it's the sum over RR such that it's not the same as R is the same as summing across all RR and then subtracting off the diagonal. Okay, so it's just a different way of doing it. Once I've got the model, the reports generated, I want to display them, but I want to not have it, again, I don't want GAMP to be giving me all these little numbers. So I say filter it at 0.1. So anything is less than 1/10%, drop it. and then report. So that if I run this model, and the beauty of this instrumenting the model with the environment variables is I can always then just run the model as is. So I can use it like a regular GAMS model, like simply say GAMS model, and that will solve it. And if we look at what we get, if I look at model, there's at the bottom, if I go down to the bottom of this thing, there's my report. So I can see the tariff rates. I can see what happens to imports from Russia. We see imports from Russia in India and China go up by over 100%. In Indonesia, so those guys are all importing a lot more. Korea, maybe Korea should, and I think Korea maybe. Turkey goes up by 46%. Low income, so all these guys are importing more from Russia. You see what the tariff rates are. They're quite different. If I look at Germany has 380, whereas Canada has 575. So that's different rates. Okay, so that's all the data for one run. Okay, so now I have the model running. I can look at one run, but then of course the most interesting answer to any question in economics is it depends. So we want to see how does this depend on assumptions, those elasticities we have a feeling those are really important. So now if I look at this program, at the programs I have in this file, I have PSA run, SSA run, and SSA solve. SSA solve is something that gets generated on the fly by SSA run. But let's first look at PSA run. So the PSA is piecemeal sensitivity analysis. I'm first going to generate a file called, if not de-exist PSA output says, so here I'll keep making comments here. So de-exist evaluates whether a directory of this name exists in this a subdirectory in the current directory. Okay, so this says if not de-exist PSA output, then make a directory, or then if it exists, then remove it. So I'm saying here I'm going to say if we rerun stuff, one of the things I like to do is to make sure that if I run it, I don't want to keep anything I already have. So just get rid of it, right? So if it exists, I want to start over again. So I only run this when I'm going to do everything over again. And that's oftentimes what happens. You find a bug and you say, I want to rerun everything. So one of the most annoying errors is to think that you ran it, but in fact, you had a bug in the thing and you're still looking at the same results that you had before. So I find it's, to be safe, I like to say, okay, if I'm rerunning it here, to get rid of everything I have. And then I create a directory for output. Or output of GDX and LST files. And again, if we do it this way, then we don't have to worry about cleaning up the present directory. It's okay to have a few working files in present directory. When you do sensitivity analysis, it's good to create a subdirectory so everything gets moved off. And that way, if I want to clean up, I can just dump it. So here we get to something that it's been good actually, because Martha works with Apple, and it's been good because that way I'm forced to actually learn how the world works in different ways. And one of the things that's different is the directory separator is a / in Apple, it's a / on Windows. And so that's the feature of the world. And so I do here is GAMS gives you a thing called system.dearsep. Dearsep is the directory separator where there's 4 / So I say set ds system.ds, that gives me a / into ds, and I can use that. Notice here when I say, so what am I saying on the output? I say GAMS model epsilon equals 0.2, eta is equal to 0.25, sigma is equal to 4, GDX equals PSA output DS low eta. So that generates a GDX file with that name. And then I also put the listing file out into the same subdirectory. So I'm running the model with a specific set of assumptions with names on each of these scenarios I run, and I move all the listing files out to the subdirectory. And this is useful again if I look at PSA output the directory. Then you can read from the file name. You know what the scenario is you've run. And so that's the reason when I have a model, the first time I'm getting a model set up to do analysis, I do a PSA because it's easy to check what's going on. You can look at you know what the scenarios are. And for many applications, that's all you need to do. You don't need to do the systematic thing, is not always needed. It depends on how thorough you want to be about running stuff. But this way you get the listing files and the GDX files. And so that gives us. And here I've shown, okay, so here, when routing output to the PSA output directory. It'd probably be easier to do it. Let me just do this for fun. So I'll say set out dir PSA output DS. I'll define then I can say replace string PSA output underscore DS to be out dir. So that way that just keeps things a little bit, just to have a shorter string. So now I'm going to say, so here I'm going to say define an environment variable with the okay, now launch all the scenarios using the start and so they run in parallel. Again, this is one of these things that takes some time to get accustomed to. When it's taken me the last, I think I made the transition to doing this about 4 or 5 years ago. But now I'm completely, if I get on a machine that doesn't have enough cores, I immediately notice that it's a pain. So what's cool here is that you've got a processor that has 4 cores that gives you eight threads. You can run 8 scenarios at the same time as it takes to run one. So that's what makes this approach is very useful, because when you go to rerun stuff, it doesn't take that long, and you can load everything up. So the start command is helpful to know. So this is where we're using that. The /min says, don't pop up a window, just keep it in the background. Right? So that's the start, and you put in a name on the window, so that way when the thing's running, now this model is so tiny that it doesn't run for very long, but when you're running a big model, it's always helpful. You have to put the start and the double quote. That's the so I run in parallel, the string and double quotes after start. Inserted after start is the window title. /min indicates that a window should be minimized. Right. That's just my habit is to launch the stuff, let it go. And this is the reason why that, you know, if you're using GAMs regularly and you have bigger models, it's worth the time it takes to get a faster machine is definitely worth it. So it's like there's no doubt about it. So I'm a huge fan of I like the Lenovo ThinkStations, which come with the Threadripper chip that has 16 so you get it 38 megabytes. You basically get as fast a chip as anybody has, and then you basically it saves you a lot of time in the overall time. This is it's a good investment of time. Now I'm going to say, okay, I'm going to write a log file. So I'm going to write a message to the log file to tell them, hey, the scenarios are running. When they're done, hit a carriage return and we'll proceed to do the rest of the processing. Because here, in this script, we'll both launch all the scenarios, generate the GDX files, and then it will proceed to combine all the results from all the GDX files to produce the pivot report. So what I'm saying here is like, okay, I generate a message, I issue a pause, and now I'm going to use the GDX merge command line, the GAMS command line utility. GX merge to bring back together for scenarios which we have run. Okay, so that basically grabs everything together. And so the way the GX merge, notice that the GAMS directory system directory is automatically added to the path for this call. So you don't need to edit your environment variables. There are your path specification for this to work. This is an aside. Okay. And the parameter I'm asking it to merge the ID PCT. And then I'm going to say GDX XRW, that's the command. And that's, oh, I'm sorry. This is going to be, this should go here. I made a mistake here. If file system is equal to Microsoft. So GDX XRW is the tool that moves data from a GDX file into an XLS file. I'm saying if the system we're running on is Microsoft, so you say if the file system is MSNT, then grab the results grab parameter PCT from merge.gdx, that's the output from the GDX merge statement, stick it into Excel file called PSA results.xlsx, put in a range called pivot data, starting in cell A2 with no dimensions on the column. So that means that we're going to take this three-dimensional parameter and stick it in list format in the output file. So that's the format that's familiar. The beauty of this is that we go in and mess around with this worksheet, putting in the spread in the pivot report. We can rerun the thing and just say refresh, and it'll pull everything in. Right? And finally, if we're running, doesn't really matter if no matter where whether we're running on the PC or running on Apple. So the creation, the dumping of the results into a CSV file is easy to do. One parameter that's useful. So so it can be imported into Excel either on a Mac. Also, if when working with the large models, it may be necessary to read the CSV file, to use the CSV file with using the GAMS data model. Okay, so the GAMS data model is for large things. Yeah, I'm not going to dwell on that, but this is helpful. Notice here what I say is GDX dump, merge.gds, the symbol I want to, and this is annoying. The other one says ID and this says SYMB. That's the reason I never remember I always have to regenerate the thing to see what the commands are. Symbol is PCT, format is equal to CSV file, output is equal to the name of the file, and then I say what the header is. That's what the labels are I want to put on the columns, and that way everything is sitting there in one setting to be imported. And so that this all runs together. Let's just verify that this guy runs. So I say PSA run. It launches all these guys. All scenarios continue when these are finished. They're all finished. That one's closed. I'm just making sure I don't have anything sitting out here. And so and then it merges. You can see it reads all the files to merge them. And then it generates the GDX XRW. It goes to PSA results. So that moves all the stuff through to the results file. You say PSA results .xlsx. And this guy has, so there's the pivot report. There's the region, the item, the value. If I go to the pivot chart, I then can go right click, say refresh data. That'll pull the data in. Now I'm doing a little bit of I put in a list here of items and I declared that to be range items. And I made them, and I organized this alphabetically on the left. So they're sorted. And then in my pivot table, I put in a cell where I said, do a lookup of the item in the items range and pull back the description. It just makes it possible if I go to the pivot chart and I change a different item, I go from here to say P, then it changes the title at the same time. So that's something that any MBA student would know how to do that, but I learned that this year, so I'm excited about it. Okay, so that way you can have the thing sort of lined up. And so then this is a format where you can do some digging around. You can grab a bunch of other stuff, and it's a format. The PSA is nice and it's very lightweight. Just run the things, put it together. You can put a report, then you can, and if you have the generic one, then you can run more and you can do additional pivot tables and save them all, and then you can save it with your boss, and it's very easy for them to sort of see what you're doing, and you produce it. What I like about it is you can produce stuff that looks relatively polished, but it's really not that much programming. It's you know, a little bit of work. The SSA run is here as well. This is a little bit more involved. I don't know, are there any questions? Let's see, I have one question in the chat. Okay, yeah. I'm sorry to be this morning. I'm just doing this because I felt that I didn't do a good job yesterday, so I wanted to make sure. You know, yesterday we wanted to learn how to do this. In terms of stuff that matters for GAMS, I'd say this is really high on the list. This is beyond. Yes, you want to learn the theory, you want to learn where data is, you want to learn how to build models, you want to do all that stuff. But the very beginning things, you want to be useful out of the gate. To be useful out of the gate is like somebody sends you a GAMS model and says, here's a model, look at you can run it and get my results. And the first thing you want to do is to say, how does that depend? Does it matter? And so that's where the first thing you do with someone's model is, I need to instrument this model so I understand what's happening. And so that means immediately I think, well, what do I want to change? What do I want to get coming out? And the beauty of this approach is that you basically script all the process of generating the model. And you can do that early on in the process, and the script doesn't change, but you can change, everything gets reported, you can make lots of changes in the reporting in the model, and you always have the button there that says regenerate my results. So when you change the model, just hit the button and everything gets redone. So that way you have it relatively compact. I'm trying to do a sales job. I know you guys are people who come from the GEMPAC world, which is a great world. These guys, I like the Australian guys. I think they're great. They're ultra smart. I mean, Mark Horridge is a fantastic programmer, just utterly fantastic. But it's a different world. It's like, if I want to be disparaging, the Australians are always chippy, so I like to be chippy back. It's like, they like to produce tools for people who like to live in a padded cell. So if you like to live in a padded cell, GEMPAC is for you. If you want to basically have control over your own stuff, then develop good habits for how to do this. And you basically can use the tool. Once you develop this habit of how to do stuff, you can take a model any model, and this doesn't require that you understand the model. You just need to know, what do I want to change? You find where in the code do I want to put the switches in, and then you're off and running. Okay, so GAMS, so what's the cheat? What do you want to learn?
So when I'm looking over a GAMS code that's not so beautifully well described, right? Is there a place where I can figure out the headings of each thing that it's what's happening? So declaring the set, whatever. Here's instrumenting the model, here's the parameters for the model, here's the tables for the model, right?
I'm afraid that, so the thing is,
Any description.
yeah, that's the problem, is that GAMS gives people a lot of rope to hang themselves with, and a lot of people go out and hang themselves by writing code that's indecipherable. So that's the problem that we have, is that it's the fundamental problem of freedom and responsibility, right?
Right now.
GAMS is used for many different modeling applications, and every modeler does things a bit different within that possible framework. So there's
no specific order of operation.
no. Okay. But I can show you later a few things in the GAMS documentation.
Okay, that'll be all.
So I have a thing. Over the years, I have this web page that I just throw stuff up there, and it's like I'm not nearly as Markuson is like ultra organized and careful. He thinks about how this. I just throw stuff up there, and I can't remember what they do. But I do have this nice thing up there, before versus after illustrating the virtues of set notation. Right. So this was just a program. People would send me, when I was younger, I was like a industrious, hardworking. I would debug people's GAMS code for them. And so there's an example of, this is how it looks beforehand. There's the email. And so this has all these names looking like that. So this shows the whole, there's a model. This one doesn't look so bad, but it's like, it's got all of these identifiers, which are kind of hard to understand. And then there's the way it looks when it's organized, right? So there, I've defined the sets. So the main problem you have is, you're saying you want to know what the GAMS statements are. More the problem is that people don't think in a structured way about what the components are of the model. So they get, a lot of times you have embedding of multiple sets into one identifier. And that's actually, like, that's really hard to unwind, is what's going on. So yeah, if the code is a mess, it's very tough. But this shows, this shows before. This one's not as dramatic as I thought, but basically it's helpful. You know, it's helpful to have, if you're getting a model that's nice and clean, that helps a lot. And I don't know how to answer. I'm trying to provide here is that the PSA run and is provided for you as a template you could use. So you can grab this guy, pull it into the directory, say, what do I want to change? Don't do too many at first, two or three. You can always generate another PSA. You can do multiple PSAs, but put in a few, put the instruments in the model, verify the model runs. The beauty of this is the model is sitting there, it's still operational. So here, model.gms, I can run the model, nothing changes. But now I can instrument the model with the PSA. Now I'm doing the SSA, which is, I don't know, there's a way I've done it, and so I'm showing you how I did it. I originally started off yesterday thinking, I want to hide you guys from the complication. There's one operation we do here that's tricky. So there's one tricky operation. And so I'll try to point out to where that is, and you may find it hard. And really, I think that for most cases, the PSA is going to be enough. But if you want to do an SSA where you systematically vary things, then you need to declare a set. And to do that, you need to declare, again, we're doing the same thing. There's the directory separator. And we start off by saying, okay, I'm going to give the values of I'm going to declare the 3 parameters. And now I'm going to give, for each parameter that I'm going to use to control the model, I'm going to declare that parameter as a set. In the PSA, we only pass it on the command line. Here I declare it as a set. And the set tells you in the sensitivity analysis, what are the values that it will be assigned to that one. So here I have the epsilon having values of 0.1, 0.25, 0.5. Eta has values of 0.5, 1, and 2. Sigma has values of 2, 4, and 8. Notice the 2, 4, and 8, I don't have to double quote because they don't have a dot in them, but the other ones have a dot in them. So I have to be careful. And anything, I want that to be a scalar. I don't want it set. It's a one-dimensional set, not a two-dimensional set. So I have to quote those guys. It's also going to be helpful. I'm going to need to know the regions and the items when I manage the reporting. So here I run the model, action equals compile. It says just compile the model, don't run it, and generate a GDX file. So that gives me all the symbols from the model. And then I retrieve those models at compile time. So I basically say, I'm going to load R and item. Item is the set of report items to the model, and R is going to be the set of regions. Because down below, in this program, I'm going to solve the cases and then pull everything back and generate the report. So I need to know those two sets. I could have written the sets in here literally, but I want to write this code so that if my model changes, I don't have to remember to change the reporting. This will automatically, if I change what the set of regions are that I'm using in the model, this will automatically get updated in the reporting here. Now here's, this is, so advanced NB. So that's, I calculate the number of scenarios in the SSA. And here I use this thing called $eval. It says do a numerical evaluation at compile time and put the numerical value into a string called NSCN. So NSCN now will be a number that tells me the number of scenarios that I'm running. How many scenarios I run depends on what all the combinations are of inputs. There's 3 sets of inputs, each has 3. There's 3 sets of inputs, each has 3 options. That gives me 27. So that will be N scenario will be 27 that I have. That's how it gets evaluated. If I put in more, this will tell you how many different cases you have to solve this guy. So then I'm going to say, well, the scenario indices will be 1 through the number of scenarios I'm running. And now this is, again, so we have to define a mapping. Which can, a tuple. Which maps scenario number to the input assumptions. So I'm going to have scenario numbers 1 through 27, and each one will have a given set of assumptions. So this tuple tells me scenario 10, what were the assumptions I made in scenario 10? This tuple will keep track of that. Because I need the tuple after I've solved scenario 10, I need to pull those guys back to put them in the pivot table. And so this is where I have to keep track of what I've generated. I originally wanted to avoid having to do this. Yesterday, I was thinking I could do this without. This is the easiest way to do it that I know of. There may be some other method. I'm hoping somebody in TV land, one of the participants here, can send me an email to say, oh, there's a much better way to do this, but this is the way I've done it in the past. And it's mainly just if you want to run a systematic sensitivity, you need to enumerate all these cases. So then I declare a counter for the scenario I run. Well, I don't need an operation here. And then I'm going to say, okay, I'm going to generate a thing called SSA solve, which will be another GAM script, which will just issue the solve statements. I say, okay, well, I'm going to write this file out. I want the label width to be 0. I want no decimals. I want the numeric width to be adapted. I set the numeric width to be 0. And I'm going to start out with a fresh output directory. Always run from scratch. So SSA output, if it exists as a directory, I remove it, and then I create a new one. And now here, so I'm going to say here, so here I'm going to say I'm going to loop over the first element of the index set. So SCN is the scenario index set. I'm going to loop over the scenario, only the first one. So that means SCN, that set is active inside the loop and always points to scenario number 1. And that way my mapping says, and then I do a loop over all the possible combinations of the other input, combinations of model input. So now I loop at all values of epsilon, all values of eta, all values of sigma. I just have 3 of each, but you could put 10 of each. You'd have a lot of scenarios to run, but you could put in, or you can easily see this is easily extended. If you want to have a sensitivity analysis with more than 3 inputs, just add those to the list here. There's no change. Then I say, well, how does this map? And I'm going to say, well, the scenario I'm running is number 1 plus the number of scenarios I've already launched. So SCN plus ISCN points to what the index is, the number that I'm running. So that's in GAMS, that's called an offset. So I'm offsetting on the scenario list. And then here I'm doing the mapping that tells me, that's a GAMS syntax that tells me which scenario goes to what set of inputs. So I've generated the mapping, and then I put in on my output file, I put in GAMS model, I put in the assignment of what the inputs are, and then I generate the GDX output and the listing direction. So if I want to look at where how this gets generated, I'm writing this file right here. It says GAMS model, epsilon is equal to that, eta is equal to that. Now I didn't put in a thing saying a start. So if I wanted to put in start, I could do it so they all get run in parallel. Here I've done them all in serial. I just was being a little lazy. And you can see then that all of these get indexed. I get a GDX file called 1.gdx, 2.gdx, 3.gdx for each of the output files. So those everything in the gets saved, including the percentage changes. And so at that point, I've run the model. And now I want to basically tell you, file SSA solve has been generated. I'm ready to solve scenarios. Again, here at this point, if I run this guy, so if I run this thing, GAMS SSA run. Now I see that it gave me a message down below. It says file SSA solve has been generated. I'm ready to solve scenarios. So if I do it at this point, I can say, go to SSA solve.gms. I can double check to make sure everything is there. I can see what I have to do. And then I can go back and hit like that. And then it goes off and runs them all. So these guys, I'm doing them serially. I mean, it makes more sense to do it in parallel, but anyway, so this is, if you do it in parallel, you just replace call GAMS by call start name GAMS. And then it gives me a message saying scenarios have been solved with listing files in SSA output. I'm ready to merge the results. So now I'm stopping. I go out and get my coffee. I come back 30 minutes later. I check to see things are running. I see the message is there. Okay, I'm ready to go back to run the stuff. And that way I can double check. I can say, a lot of times, or if I say SSA output, I can look at the listing files. And to be honest, the cheat I always have is I look at the size of the listing files. If they're all roughly the same size, then they probably have all solved. If one's a different size than the other ones, I know there's something wrong. I can double check to see that stuff works at that point. And then at that point, I can say, okay, I'm ready to, now let's look at how this happens, what happens in our code. SSA run, executes the scenarios, does a pause. Now it's going to say GDX merge all the GDX files from SSA output. I'm going to grab the parameter called with an ID of PCT, and then I merge it, and then I read it. And here I read the results that are the names that it gives to me are the scenario index. That's the index 1 through 27 is SCN by region, by item. And that's the reason I read region and item as sets early on, so that when I do the when I load the thing, it knows about those things and pulls everything back. So that's the reason I had to know R and item to be able to pull it back at execution time. And then I declare a parameter called pivot data. And in pivot data, I don't care about what the index is of scenario. I want to know what the assumptions were for my inputs. So I declare pivot data to be defined over epsilon, eta, sigma, R, and item. And then I loop over my scenario map, and I do the assignment from the integer index onto the labels. Let's look at to see how this works. Let's look at let me first finish this guy. So now it pulls it out and runs the thing out. So if I go here, I say SSA results. Let's look at what we get coming back. The pivot data then, and I'm going to tell it to convert these guys all to numbers. But the pivot data doesn't have the integer numbers 1 through 27. It has the corresponding identifiers. what's the value of epsilon, what's the value of beta, what's the value of sigma for each of those runs. Once I have this, then the pivoting is easy because I can have multiple things. Let's look at, so I have an item chart and I have a region chart. So if I look at the item chart, that says for across regions, there's the item crude oil revenue for eta is equal to 2, and I see how it depends on sigma, that's the trade elasticity, and I also see how it depends on epsilon, the demand elasticity. So the demand elasticity drives things as well as that. If I change eta, that's the supply elasticity, I move it from 2 down to 0.5, then we can see the revenue then is going to go up, right? So you get all three things going on. You can look at different things, or you could say, we want to look at the effects across. So here are the items that get reported. That's going to be the tax rate. That'll be the cost of Russian crude imports. That's going to, so you get all the report numbers for Germany, and I could then say, okay, well, what region do I want to look at? Let's look at what happens to Russia. So if I go like that, that tells me what the value is for Russia. So I get an effect of what happens to, so that gives you a way of pivoting the results, and that has everything moving at once. Generally, I think you're better off, again, just instinctively, I like to first, when I begin a project, I like to get to the first draft of the paper without doing SSA. I like to do everything with piecemeal first, just to see what matters, because you can generate a scenario where you change two things, but just do it hunt and peck. And then before I generate the final draft, the second draft of the paper, I go out and do an SSA, so I have everything sitting there. It's helpful to have the SSA because then you know, one of the things about it is that you may not include all the results, and that was who's the macro guy from Minnesota who was so smart. Anyway, I remember when I was an assistant professor at Western, I flew back across the Atlantic. Ed Prescott. And Prescott said the thing that's most difficult with PhD students, it's kind of like if they're working to become a sculptor or a furniture maker, you have to get used to the fact that the amount of that you're going to have lots of chips around on the floor. That means you do lots of runs, you have lots of stuff, and you may have many runs that just show up, if you're lucky, as a footnote in the paper. In other words, lots of stuff that doesn't go in. So this is an example where you may have lots of different runs. You have an intuition about what thing drives things. And that's the reason I like to do the SSA, just so I can see how stuff goes. But it's not, the fact that I have this doesn't mean it goes into the paper. I'd say just in terms of the input here, if I look at the item chart, that's the region chart. If I look at the item chart and I look at the thing that's interesting here is going to be what happens to, the crucial thing is what happens to C times Y. That's going to be revenue. You can see here that the, you see that the revenue goes up a lot in Germany because Germany is the most affected by this. Sort of dramatic, the percentage change there is the most dramatic, but they don't have a very large industry. And then if I look at an item being what happens to the tax rates are quite different, right? And this shows at low elasticities, the tax rates change quite a bit. So the tariff rates depend, these elasticities will drive a lot what the marginal cost is, what the effective margin is, how much you have to tax effectively, and the tax tells you how much incentive there is for free riding, right? So this wedge matters. On the other hand, if I look at the item here, and this is where it's different than my intuition coming in was this would be a big factor, but in fact, in terms of what it does to what was it, X C times Y. Oh, I'm sorry, for the region chart. If I look for Russia, if I look at what happens to, so that's Russia. If I look what happens to C times Y, the, oh, it actually is. So depending at the lower elasticities, it's much higher. The amount by which they lose is relatively modest. So basically, oh, I'm sorry. What I want to look at was how much, what happened here was going to be what happens to their imports. So what happens in these different scenarios? Because I said, why would you, I went at this thinking, oh boy, because of these trade effects, price effects, it matters. But in fact, in terms of on the primal side, what the policy looks like, if we don't think about it as a tariff, we just think about it as how much they abate. In almost all cases, for almost all elasticities, it says full abatement is what's called for. So here, if eta is equal to 2, it's almost all 1. So at low elasticities, when it's really low, here I'm looking at the coalition states are the ones at the bottom there. And there's a little bit of, it's a little bit less, it's around 90% in the case if it's very low elasticities, but otherwise the policy says abate all the way. And how much leakage you get will depend on the elasticities in this scenario. So that's an example where the model told me something I didn't expect. I thought you might not want to abate all the way, all the imports to 0, that the optimal policy might be something different than that, and particularly for low elasticities, but it turns out not to be the case. So my intuition was wrong. It's the reason you want to have smart co-authors like Markuson, because he knows he has the intuition right from the get-go. I told my John Wally story. Did I tell my John Wally story? I think I may have. The first time I worked with Wally, I mean, we were going to work on this conditionality and dilution, this basic sort of stuff. And I'm just an engineer. I've taken 3 economics courses in my life, and I'm trying to learn how to do economics. And so I'm also kind of suspicious of economists. I think they're all sort of snake oil salesmen that make stuff up. So I'm very skeptical at the get-go. But right. So Wally says, okay, we're going to do this run, and it has this story. The story he has is that we're going to change the rules for set-aside payments on land, and this will cause a change in the return. You can set aside up to 25% of your land, you get paid the average price. This has a big effect on capitalization into properties that have exactly 25% of their land is crappy. So if you have a farm that has exactly 25% is crappy, and that's the cutoff point, then suddenly that 25% is fully valuable. If half of your land is crappy, it's not as valuable to you, but 25%. So John wants to simulate this. We get characteristics of all the land. We have a big database we're working with, but we have the first lunch. We're going to talk about what we're doing the model. I haven't done the model yet at all. We've looked at the data and talked about it. And John, then we go back to his office and he says, well, I have some ideas about what the tables and the figures should be that go in the paper. And so then he gets out a pad of paper and a pencil and he proceeds to draw the figures that will go in the paper. And this, I'm like completely horrified. This is what I suspected was he just makes up the numbers, right? But then he takes the figures he's drawn and he puts them in his drawer. And he says, okay, now go run the model. When you come back, then we'll do the figures in the model. And then we'll look to see whether our intuition was right or wrong, right? So he always would do that. He would take a guess at what happens, put it aside, and then you run the model and you compare the model because that affects the way you write the paper. He says, if it turns out that the results, the intuition we have from our elegant story is wrong, then we don't have this elegant story to tell, but then we write a pitfalls paper. Then he'll write the paper that says, you might think that this would happen, but let me tell you why that doesn't happen, right? Which was, this was a real eye opener for me. It's like the model is very important, but you also want to go out on a limb and take a stab at what you think is going to happen. And then you run the model and see what's going on. And here it's not the same as what I expected. As we know, when elasticities are low, the cost of the policy is great. There's going to be more leakage if elasticities are low. That's just the way it goes. But how much abatement says if you're trying to maximize your damage that's done to the revenue that's received, set the imports to 0. You can't, but you know, not abating, yes, you're going to reduce leakage, but still with the damage. So that's sort of that's the intuition we get from the model. So I'm done with that one. Yeah, so we'll take a break now for half an hour. Yeah.